Right. Hi, Calvin. I just wanted to give you a response to your video and show you in practical terms how we could use AutoCAD software to demonstrate that the angles work with respect to construction and a global Earth on a global scale.
You tell me where those three levels are going to curve to make any allowance for any curvature. So, for you to just send me a simple video trying to explain this, just show me a simple video. I will send you the 10 grand.
Okay, Calvin. No complex formulas here. Measurable, observable, repeatable. Let's go. The first thing I'm going to do is change the units within the software so that we can practically use them within the software representative of the real world. So I'll type in units, and you can see I've already got it set up here, where units and scale as at kilometers and our decimal degrees in precision is already set to default. So the first thing we want to do is to create a circle that's representative of the global Earth. Easiest way to do that is to find the radius of the Earth. And here you can see we've got 6,371 kilometers, I guess is the average. So let's just use that. So I'll jump back into AutoCAD and I will make a circle with a radius of 6,371 kilometers. There we go. There's our nice blue global Earth. What I'll do now is I'll just draw a white line from the dead center of the Earth right to the top of the North Pole here, I guess. Looks like we'll be building a building on the top of the North Pole. So let's click on that line and we can see that we have a radius of 6,371 kilometers. Same as they say right here, 6,371 kilometers. Right. Okay. So let's zoom all the way in here to the top of the North Pole. Well, would you look at that? You can see that the horizon is starting to flatten out. It looks like a flat line. Anyway, it doesn't matter. So how big should we build our building on the top of the North Pole? Well, I think we should build the biggest building we can that's practical. So the biggest building on the planet right now, or the tallest building, is the Burj Khalifa, and it's 828 meters, 830 meters to the tip. So let's just copy this. 830 meters seems like a pretty reasonable height for a building. Kind of unreasonable, but at least it's doable. We've proven that. So let's draw a line 830 meters high. So I'm going to type in 0.830. There we go. So that line is, just to prove it to you, 0.83 kilometers. Perfect. Okay. So how wide, I'm just going to make this a different color. I'll make it red. All right. So how wide should we make this building? Well, I say if we can build a building that's 830 meters high, we can also make a building that's 830 meters wide. Make sense? Okay. So what I'm going to do is, to make this building 830 meters wide, is I'll offset this line by half of that. So we're going to go 0.415, which is half of 830. We'll do one on that side, and then we'll do one on this side. Okay. Now we can get rid of that line in the middle, and I'll give our building a roof, and I'll give our building a floor. Okay, and I'll change these to the same red color just to keep things consistent. Now, what is the angle of the roof and the wall and the floor relative to one another? Well, it's easy to find out. We'll just do a quick angular dimension here, and you can see that we've got 90 degrees. Okay, that makes sense to me. Hope it makes sense to you. Just to prove things to you and make things consistent, I will do the same thing again. This line here. Yep, we got 90 degrees there. And just so that you're 100% on the same path that I am, we'll do this one too, 90 degrees. Excellent. Okay, so this is where the construction comes in with your plumb line. Right, I'm going to change colors here, and we're going to make some plumb lines. So you've got your little construction worker here at the top of the building, and he wants to make sure that as he's constructing this line is dead straight. So what he's going to do is he's going to drop a plumb line from here straight down. And when we're talking about global Earth, we know, and you've even said it in your video, that that plumb line goes all the way to the center of the globe. Boom, there we go. Okay, and we've got our construction worker buddy on the other side, and he's going to also drop a plumb line. Look at that. Those lines look like they're dead parallel, don't they? We're going to drop a plumb line all the way to the center of the Earth. Right. Okay. Now, based on your video, these lines should be dead parallel, right? Because the way you explained it, those plumb lines, they would fall down to the horizon. They would be 90 degrees. So just as we've measured this as 90 degrees and this is 90 degrees, the distance or these should also be at 90 degrees to the horizon. Well, I wonder if there's any degrees between them. Let's have a look, because if we do anything or make any measurements between these two, they should be parallel, 100% parallel with one another with no degrees. So basically 0 degrees. So let's just do a quick angular dimension between this line here and this line here, and let's see what we get. Oh boy. You might be right, Calvin. 0 degrees. Does that mean that they're completely parallel? Oh, wait a minute. I know what I forgot to do here. I need to go into AutoCAD and go into the angle precision. Right now it's set to 0. Let's see what happens when we do this. Interesting. Wonder what that means. Okay, and similarly, what we can do is let's just delete that angle there. And let's see what the angle is between this line here and this green line. Okay, let's do that. Angular dimension. It should be 90 degrees, Calvin. Okay. Oh, yeah, 90 degrees. Yeah, right. Now let's check the scale, or sorry, let's check the precision of this angle. We'll go all the way here. Interesting. Not quite 90 degrees. I wonder what that means, Calvin. I wonder if that means that we could actually be living on a global Earth. So what you don't seem to understand, Calvin, is that the scale of the Earth matters when it comes to plumb lines and measuring angles. That when a construction worker drops a plumb line from the top of a very tall building to get an absolutely a 90-degree angle, in this case, it's not quite 90 degrees. It's just off slightly if they're using a plumb line. Nothing would be noticeable by the human eye. You'd have to have some sort of an instrument that was extremely powerful to measure the variation in the angle. It looks like a 90-degree angle to me. It looks like a 90-degree angle to you. But in real world terms, if we had a building that was 830 meters wide or 5 meters wide, and a plumb line was used to make sure that the angles were parallel to one another, there would be variation in the real world because scale matters. Anyway, I hope that was practical enough for you. I'd really like to have that 10,000 pounds. So I'll send you some instructions on how you can get it to me. I take cash, Bitcoin. I'll even fly over to see you from Canada if you want. And you can hand me a stack of cash while I'm there. It'd be great to see you and have a cup of tea. Right. Well, any questions or concerns about the way I've done this demonstration, Calvin, please let me know. Cheers.
So, people say put your money where your mouth is. There's my money, right next to my mouth.